There are 6 penetration stages covered by the CompTIA Security Plus exam. The first is Passive Reconnaissance, followed by Active Reconnaissance, and next we have Initial Exploitation. After we gain access, we are going to escalate privileges on the target system. Then we will establish persistence on that system. And then finally, we will pivot to a new target inside the targeted network. Passive reconnaissance is research without giving the target organization an opportunity to detect your activities. A lot of this research could be done on Google. We could use Shodan to see vulnerable systems associated with this organization. We could check their DNS records. Sometimes dumpster diving could be considered passive reconnaissance, as their automated information systems won't have the opportunity to detect you. And we also can browse their website and see what information is available about the organization on the website. So passive reconnaissance includes all of our research activities that don't provide the target the opportunity to see that we are engaging them. Active reconnaissance involves directly interacting with the targeted organization's systems to determine information about those systems. This primarily involves scanning. And the most common scanning tool is Nmap. Nmap allows us to interrogate systems for their open services and will attempt to identify, depending on our scan settings, what version of that service is running, so we could target that for later exploitation if it is vulnerable. In our passive reconnaissance, ideally we have identified some IP ranges for this organization, so from our target system, we are going to begin interrogating these systems. In their demilitarized zone, we have servers that are accessible from the internet. Now the firewall might be restricting which services we're able to communicate. It should be restricting only to intended services, so they should be restricting to perhaps port 80 and 443 and maybe 53 for DNS, but it could be blocking all other ports than those intended for end users to access in this DMZ. But we will attempt to contact these servers on the 1,000 most common ports or any custom setting that we've identified. We'll interrogate the firewall, and if we have enough information, we're going to attempt to interrogate the internal servers and the workstations, but this traffic will likely be blocked by the firewall. There are other types of scanning outside of Nmap, which is going to do a generic identification of services. It also has some custom vulnerability scripts we could run, but perhaps we're going to do some SQL enumeration. We could scan their SQL servers, see if there's any vulnerabilities there. So there could be any type of specific application scanning. There's a lot of scanning tools available in Kali Linux beyond just Nmap. So we'll do any kinds of our scanning in our active reconnaissance, interrogating systems that we can communicate with. After I've done my passive reconnaissance and active reconnaissance, I'm going to try and gain a foothold into the target network. This is my initial access. There's 4 methods that I might use to gain my initial access: remote code execution, browser-based exploits, file format, or physical attack. With remote code execution, I am targeting a vulnerable service running on a distant server or workstation. It allows me to send exploit code over the network and gain access without any interaction from the user. So let's say in my active reconnaissance, I determined there's a vulnerable SQL server in the DMZ, and that port is open from the internet at large. I'll send my malicious packet to the server, the payload will execute, and then I'll get a call back with a shell, give me access to that system. That would give me initial access. I could attempt remote code execution against a workstation. However, a well-configured firewall should stop any traffic from the internet targeted at these internal workstations. I wouldn't expect remote code execution to get into the internal network to be effective. Instead, I'm going to need to use social engineering to target the users. This will either be a browser exploit or a file format exploit, most likely. A browser exploit is an exploit of Internet Explorer or Mozilla or Chrome. It could either be they have an older version, or you have a 0-day for one of these browsers that you know that their internal users are using. So in your reconnaissance, you might have identified their email space or their email server. If you're doing a browser exploit, you're going to create a malicious website and then send a link to that website to their email server. Email server gives that email to the workstation. User clicks on the link, which goes back to your malicious site. When their browser opens the site, the code executes, and that's going to create a shell on their workstation that will call back and give you access to their workstation that way. A browser-based exploit could also be used in a watering hole attack. We know all of these corporate users commonly access a single website. We could compromise that website that's external and then host our malicious code there as well. So when the users connect to that website next, that malicious code executes, and again, we'd get shell access, although that would be more complicated and a less common way to get initial access. We could also use a file format exploit. This is targeting either a Word document, an Adobe PDF, some file type that when a vulnerable application opens it, when it's parsing the data in the file to present it to the user, perhaps it has some type of bad parsing where it doesn't properly control its bounds, and we have some type of buffer overflow that allows us to execute code when you're opening this file. So we send them a malicious PDF, taking advantage of a file format exploit. This is social engineering. I email them the PDF. It gets delivered to the user. When the user opens the PDF with a vulnerable version of Adobe Reader, our remote code executes and calls back to us, giving us shell access to their system. And the final thing I'll talk about for initial access is we could have physical access. If you have physical access to the system, you're physically on site, able to social engineer your way into their work center. You can always use that physical access to establish logical access to a workstation. If I use the Metasploit framework to gain my initial access, I'd now have an interpreter shell on the targeted system. But if I used a social engineering attack, I probably have access in the context of the user. As the user, I only have limited rights on this system. To finish my engagement, I need to escalate my privilege to a system, administrator, or root level account. For privilege escalation, I'm going to use another exploit after my initial exploit to get this initial access to elevate my access to that of the system or administrator account. Interpreter has a built-in command. Get system will try a few different common exploits that affect versions of Windows to give you that system level access. Alternatively, if that doesn't work, you'll have to find another exploit, perhaps even exploiting another vulnerable service on that system now that you have that access as the user to escalate your privileges to that system, root, or administrator account. After I've established my system level access, I want to establish persistence so that I can come back to this system in the future and I don't need to social engineer another user to gain an initial foothold in this network again. I'm going to install some kind of backdoor so I have access that persists for the duration of the engagement. If I'm using the Metasploit framework, I can use Interpreter, which has a built-in model for persistence, run persistence. This will install or provide an executable file on the system and then modify registry keys so your executable file will run on startup every time. We could also install a backdoor, or we could create a user account on this system with credentials that we have, ideally a system account, so we could log into the system later, or we could create a scheduled task that runs an executable program that calls back to us. The point of any of these actions is to maintain our foothold that we've created in this network so we can come back to it later. Now that I've established my persistent access to the workstation, I want to move to other targets in this network. While I was previously unable to use remote code execution to gain access to a workstation, because if I tried to communicate with them, it would have been blocked by the firewall, these workstations have a trusted relationship that I can exploit to move laterally within the network. While port 445 might be blocked coming from the internet, workstation to workstation, that traffic is probably allowed. So maybe they're unpatched workstations that I'm able to use an exploit like Eternal Blue, or maybe I'm able to pass the hash between these workstations using psexec. So I'm going to route all my traffic from my malicious system to this workstation I have access to, and use that access to pivot to another workstation. Now the workstation probably wasn't my end target in this engagement. I'm either looking for some information, trying to gain access, some way to gain money, some way to hold their whole production at risk. I'm likely trying to gain access to one of the internal servers. And fortunately, while again these internal servers should have access blocked externally at the firewall, an internal workstation is likely able to communicate with these servers. So if I'm able to identify a vulnerability, I can pivot from this workstation to one of the internal servers. And from here, I'm going to pivot or move laterally throughout this network until I've accomplished my objectives and gotten what I need to do, or the defenders detect me and kick me out. Of course, as I'm pivoting through these systems, the process does repeat to some degree. I will do active scanning from inside the network. I will do access to the systems. I'm going to escalate my privileges, and I will establish persistence on some of these more interesting systems to try and maintain my access as I progress through the network.